Welcome to the online version of the training for CEUs called Basic NEC Rules. So as you're getting online CEUs, there's a couple of things that you need to remember. So I want to hit them right up front, and then I'll remind you again once we get to the end of the program. Don't forget that there will be checkpoints in this presentation. So every 15, 20 minutes, some variation in there, you'll have little questions that will pop up on the screen. And those questions will basically ask you, something generally speaking that will just require a response within a certain amount of time to indicate that you're sitting in front of the presentation and actually watching and learning and kind of interacting with the program. So as we move along, you'll have those interactions, and if you get a question wrong, and don't worry about that, it'll send you back a couple of seconds, and then it will pop up again and ask you for the answer again. It's only if you don't enter anything that you go all the way back to the previous section and have to recover all of that. And if you leave and don't get to make it through the section several times, what it'll do is it'll just time out and you'll have to redo the entire program again. So one last thing to remember, once everything is finished, and by everything finished, what I mean is when you're done watching the presentation, if this is in sections, you'll watch the first section, and the second section won't pop up until the first section is done. So you'll complete the first section, it'll take you back into your course management screen, and then the second section will appear as well as the first section. You'll be able to watch the first section again over and over a few times for a certain amount of time, but you have to complete the second section and the third section. Depending on how many sections you've got, you'll have to complete them in order. And if there's any questions involved, you will also need to answer any of those questions. And when all of that is finished, at the very end of the program, there is a certificate that will pop up. So you'll want to make sure that you are printing your certificate and saving your certificate to your computer so that you have a copy of that going forward. That's going to have your course ID number on there, as well as what the course was good for, just all around something that you have to have. So make sure at the end of the program, no matter how long it takes you, that you complete the course by printing your certificates. So continuing on with the basic National Electrical Code rules. The program here is designed to give you the rules that are basically laid out in Articles 90 through 110 of the National Electric Code. Should give you a good firm foundation as to how the code's designed to be followed, and also give you a good base foundation in what the actual code requirements are. Rule number 1, we'll head into Article 90, which is your basic introduction into the National Electric Code. And it is going to deal with, beginning with, practical safeguarding. Now, practical safeguarding is kind of an interesting subject. Not sit on the edge of your seat type of interesting. However, you got to remember that the whole purpose of the code is to make sure that things are installed properly. It gives us a basic set of guidelines so that you protect the people as well as the property by getting rid of some of the risks along the way that are associated with electricity. So, sum it all up, make sure that you don't damage or burn down the building or injure or potentially kill any individuals that are either working there or that are on the job site for any reason. So again, what are these risks that are associated with the electrical field that the NEC is trying to address? Well, again, it's pretty simple. don't kill the electrician, and don't burn the building down. We are always dealing with electrocution and fire. So as you go through the National Electric Code and you think to yourself, oh my goodness, why in the world did they do that now this year? I want you to sit back and look at it with an objective point of view and say to yourself, okay, is there something that they've done here that has either increased the likelihood that I'm going to make it out of here safely, or increase the likelihood that the building is going to be better off, or the residents in it. So those things are always taken into consideration. Code committees don't get together and look at this stuff and think about how to make your life harder. They get together and try to think how they can make the industry better by increasing the standards without making it more difficult and expensive. Sometimes those things don't lay out that same way. Oftentimes increasing safety and increasing the value to the industry by creating better, more efficient appliances and such does increase the cost, but you've got to outweigh practicality and safeguarding together and make sure that it makes sense. 90.1b deals with adequacy. So what are we talking about here with adequacy? Well, the whole idea of the code is to deal with requirements that are surrounding safe installation practices. Adequacy means that you're installing stuff in compliance with the code, but also in compliance with what the customer needs now. We've all seen some terrible, terrible things out in the field. And I want you to keep in mind that the whole purpose behind this presentation and the code book in general and your code officials is to prevent this stuff from happening as often and as as unintrusive as we can. Look at this again, adequacy. You can't always plan for how customers are going to use things. The installation that's behind this 6-way splitter is just a regular receptacle, and that was installed correctly. The spacing is right on the wall, the height is fine, everything is installed the way that it should, and it was inspected, so everything was good. Customer takes the cover plate off, puts on a new 6-way splitter, and if this was in a room that had 4 or 5 receptacles that all had splitters on them, and we could be causing a potential problem. We could be overloading that circuit because it was never intended to have all those receptacles and things plugged into it. But you can't plan for that. And the only way you can plan for it is if the customer lets you know ahead of time, and oftentimes they do not. So 90.b, dealing with adequacy. The plan for its expansion only comes into play, in the code. Now we're talking about what does the code actually say. Plan for expansion only comes from the customer. And code says that your job is to do what the customer needs and deems necessary today and asks for today. It's not your job to drag out of them what they're going to be doing 2, 3, 4, 5 years from now with that same electrical circuit. And they may not know themselves. So your obligation, according to the code, is to plan for today, bid for today. However, your moral obligation is to allow them to make good choices as well. So if you know for a fact there's going to be some expansion, there's going to be things that are going to be going on in that area that are different than what they are today, your moral obligation may be a little bit different than your obligation according to code. Your moral obligation may say, I am going to have to let this customer know that if we planned ahead right now today and I bid him this, even though it's going to cost him more up front, over the long run it may cost him less because I don't have to tear out what I'm doing today and increase the conduit size or the wire size or anything like that. I can do it all up front today. Those types of things are what we're talking about here for adequacy. Again, you can't plan for what the customer is going to do when you're not there. 90.1c, the intention of the code. Well, what do you think the code's intended to do? Is it designed to be some kind of a instruction manual? Is it designed to be something that your general homeowner can open up and use as a how-to book? Absolutely not. It's intended to be used by people who are already skilled in the trade. It gives us a basic foundational set of guidelines so that everybody's installing things on the same level playing field and with the same amount of adequacy and practicality. If we're all doing the same things, then we should, within reason, be able to have very similar outcomes regardless of where the installation is taking place. Okay, obviously there's one-off situations, but if we're following the code and we're listening to our code officials, we should, within reason, be able to have very similar outcomes from our coparts. It's not designed to be some kind of an installation standard or an instruction manual for somebody who doesn't know what they're doing already. Rule number 2. Rule number 2 is going over the scope. Okay, the scope of the NEC. What does it actually cover? We look at 90.2a, and 90.2a is fairly straightforward as well. The NEC has requirements for the installation of electrical equipment, raceways, cables, and conductors for signaling, fire alarms, optical cables, and communication systems, etc., etc. Okay, there's not a lot wiring wise that the NEC is not going to take precedence over. So what about warehouses? What about offices? Farms? Farms are always a little bit tricky. What about mobile and manufactured homes? And all of these are things that we need to discuss in order to properly see what's actually covered in the NEC and what's not. 90.2A1 and 2. If you've got private property that has public lighting, it's got to be installed according to the NEC. 90.2A4 deals with utility buildings. And buildings that are used by power utilities, like offices, warehouses, garages, those are still covered by the National Electric Code. They're not exempt simply because they're owned by the power utilities. And that's important to remember. Some people believe just because the utility owns it, it's not going to have to follow any certain set of guidelines or rules, and that simply isn't true. There are utility exemptions, but these buildings and spaces are not it. 90.2B4. Communication utility exemptions. Now, the communication utility exemptions are kind of tricky. If a communication utility equipment, if you have this equipment in a space in a building that's used exclusively for it, it won't be required to follow the NEC requirements. But the National Electric Code is still going to apply to other electrical equipment like receptacles, switches, and luminaires, even in those areas. So that's important to remember because we have guys that work on cell towers and cell buildings all the time. In order to get this exemption, the FCC actually has to have labeled a Verizon or an AT&T or a US Cellular as a communication utility, which consequently those are. But there are some smaller companies that are upstarts that are fairly new that may not be a communication utility. And so everything would be installed according to the NEC guidelines. Its communication equipment is found in general building spaces. So now we've got regular communication equipment. This is 90.2b4. And it's found in regular old building spaces. It absolutely has to follow the NEC rules on the installation practices. And of course, a lot of those are going to be found in Chapter 8. 90.2b5a. Exemptions include service drops and lateral conductors if they're under exclusive control of the power utility. Now, I once heard a story while doing a class. We're sitting in class and a gentleman says, well, how do I know where they stop, meaning the power utility, and we begin, meaning the private contractor, when we're doing our service work or even new installation work? In that same class was a power utility gentleman. He worked for the power utilities. He simply says, wherever you're instructed for that location. And he's absolutely right. He didn't have quite as tactful a way of putting it as that, but he's absolutely right. You have to know because different areas start and stop in different spots on the job site. So you have to know what your power utility company expects out of you so that you know where to start and stop and bid your job properly as well. 90.2b5b deals with utility exemptions. The National Electric Code doesn't apply to installations on power utility properties if it's used for generation, transformation, distribution, or metering of electrical energy. That's not a hard one to remember. So as you see, these are the areas that are exempt under the electric utility exemption. However, the areas that we looked at earlier that dealt with the warehouses and the garages, office buildings, things like that, even though they might be owned by this same utility, those are going to have to follow the NEC. They don't fall under the utility exemption. 90.3 will go over the code arrangement, and this will consequently be our rule number 3, and it's an important one. It really is, especially for some of you crossover guys that are going between being an electrician, being a mechanical guy, being a plumbing guy. Some of the other code books don't have as much detail in them because it's not necessary, and so you have a much smaller code book. You have sections that deal with only general area. For instance, most mechanical codes, you're going to have chapter 3 be the general regulations, so everything will follow that unless it's a specific scenario, which everything past chapter 3 sets out a specific scenario. Well, the National Electric Code doesn't do it quite like that. There is so many different provisions out there that the code actually is split into more than one general area, more than one specific area, separate spots for tables and examples, and any time that the code actually references you to another code or standard, it's simply a reference. It's not enforceable. It's there to help you do your job a little bit better. So, getting into rule number 3, the code arrangement found in 90.3. The code's basically designed around the fact that it's a bigger book. There's a lot of information in there, and it has to flow. So they've created really a kind of ingenious flow as to how this is all going to play out. It's divided into an introduction and 9 chapters. Okay, when you look at the chapters, chapters 1 through 4 are general applications. Chapters 5, 6, and 7 are special applications, whether it be special occupancies, equipment, or conditions, makes no difference. We're talking about special circumstances or scenarios. And then once you get into chapter 8 is going to cover your communication systems. And you may find this a little bit backwards, but chapter 8 doesn't have to follow any of the other previous 7 chapters unless there's a specific reference in chapter 8 to those other sections. And consequently, that's different than chapters 5, 6, and 7, which basically modify the general first 4 chapters. So if it's not mentioned in 5, 6, and 7, then the first 4 chapters apply. So it's a little bit different once you get into here, but it's easy to understand once you understand how they flow. Then you've got chapter 9, which deals with tables, and it's not all the tables. It just is very specific tables that really did not fit in the area that they were mentioned, and they are referenced in several different areas of the code. So you don't necessarily have the most popular, most widely used tables, but nonetheless, this is a section that's used fairly often. These tables are running anywhere from raceway calculations and sizings to conductor fills, conduit radius, things like that, tubing bends. All of those things are covered in chapter 9. And then, of course, at the very end of the whole book, you have got the annexes. And the annexes are not enforceable. And just hearing that oftentimes will make an individual not pay attention to them. It's almost like somebody shuts off when they realize that somebody is saying that something's not enforceable. In reality, the annexes are a super valuable source that's found in the National Electric Code because they give you examples that are difficult to understand otherwise. For example, they give you the residential load calculation for the VA in a house. So if you look at trying to figure out lighting loads and your square footage and all that kind of stuff, just going through the NEC, it might be pretty tough to put that all together. Well, Annex D puts together in a nice couple of example calculations to show you from goose to gander how to calculate a residential home. It tells you the D rating values, how to figure out square footage VA for the lighting load, what the small appliance circuits are supposed to be accounted for, as far as how much VA they are. I mean, it is absolutely a priceless area in the National Electric Code, but unfortunately, oftentimes people skip over it knowing that it's not enforceable. Okay, they have to go to the code or to Google or something like that in order to find the answer that they're looking for, when in reality it's probably right there on their code app or the code book. So that's unfortunate. First of all, we'll look at the general requirements. These are the first 4 chapters in the code book. And the first 4 chapters are General Rules. Chapter 2 is Wiring and Protection. Chapter 3 are Materials and Wiring Methods. Chapter 4 is Equipment for General Use. Special requirements are the next section. Okay, these are applications that are going to fit in chapters 5 through 7. They're still going to follow all of the requirements in the first 4 chapters. However, chapters 5 through 7 may alter what was said in the first 4 chapters, which would make them, chapters 5 through 7, take precedence in the altered state because they're designed to be something special. Okay, for instance, you wouldn't want the same application in my living room as you would want in some place that has heavy, flammable, combustible fuels and gases around. That would be a hazardous location. So you're going to alter the actual installation requirements and things like that for the hazardous location above and beyond what would be found in my living room. These chapters are titled Chapter 5, Special Occupancies, Chapter 6, Special Equipment, Chapter 7, Special Conditions. Moving on to Chapter 8, which is titled Communication Systems, is really an animal of its own. The applications in Chapter 8 generally are not bound by the first 7 chapters at all, unless there's a specific reference that sends you back to an early chapter. Okay, which there are many of them. So I don't want to make it sound like Chapter 8, you just go there and you don't need to know anything else in the code. That is absolutely not true. You still have to know code in order to install DSL or cable systems or any kind of communication system, because you're going to be referenced back to grounding and bonding principles and things like that that are completely applicable in the communication systems. Chapter 8 is actually titled Communication Systems. Chapter 9, Tables. Okay, Chapter 9's tables contain all the different tables that really didn't fit in their respective place actually throughout the code book. They're referenced several times throughout the NEC, and they cover things like calculations and conductor fill and raceway sizing and all the important voltage drop. It's actually titled Tables. Here are some example tables that you will find in Chapter 9. Okay, here's Table 8, Conductor Properties. Table 9. Okay, here is your resistance per 1,000 feet, figuring out power loss and things of that nature. Next, at the end of the book, are the annexes we were talking about. The annexes are not enforceable. However, they've got all kinds of guidelines and suggestions to make your life a whole heck of a lot easier. They take large sections of code that are spread throughout and put it into one little area, oftentimes on a table or in a calculation, to show you how all of those sections are brought together to get you to one endpoint. Totally priceless section of the code book. The annexes are in alphabetical order from Annex A through Annex J. And we'll look at those here in a minute. Annex A, Product Safety Standards. If you see the very first section here in Annex A, it says Annex A is not a part of the requirements of this NFPA document, but is included for informational purposes only. Okay, here you've got Table C1 dealing with the maximum number of conductors or fixture wires in electrical metallic tubing, EMT. Okay, here's our example of Annex D, which gives us a one family dwelling unit calculation. Okay, this is only one little section of it, so obviously there's more to this calculation, and there is certainly more that is given in Annex D. There are several calculations. Here's an extended example of that calculation. Notice you can see your minimum feeder size is going to send you back to 220/40, but you've got your general lighting load, you've got your small appliance load, your laundry load. It tells you what your derating factor is for your lighting load. So I mean, you've got an invaluable source here for figuring out what a residential calculation would be. (90.4) talks about enforcement, and this is our fourth rule. Enforcement is not tricky at all. We've got people in place that are designed to help make the life easier of people that are following the rules. And those that aren't, well, you know how that goes. Their life may not be as easy, and they're usually the ones that are complaining about their code officials making their life really difficult. 90.4 deals with code enforcement. The NEC is intended to be used by the local authorities that have jurisdiction to give fundamental boundaries and safe installation practices for power, signaling, and lighting circuits, as well as communication systems. Pretty straightforward in the code, really. Okay, interpretation of the rules. When it comes to interpretation of the rules, if it's code compliant, it'll be safe. So follow the code. The AHJs aren't there just to impose their will on you. They're there to enforce what the code says, not make their own rules. And they're generally pretty good at it. And we might not always like the interpretation, but that's why we've got these guys in place. So that they interpret these rules for us. They give us a broad understanding of why something is not or is accepted. And then they also give us a good uniform compliance standard. A 90.4 reads, although the local AHJ is responsible for interpreting the NEC, they've got to do so based on their best interpretation of the article found in the codebook. Doesn't pick a whole lot of bones about it. Okay, so if something's not passed, they're going to cite you, but they're going to tell you why it wasn't passed based on the codebook. So, in my personal opinion, if you're on a job site and you're doing something a little bit different or out of the ordinary for you or for your company, what I would suggest would be leave the section of the code that you're referencing for being able to do it the way that you're doing it for the code official, so that he can see that you just didn't make up what you're doing. You actually had a reason and an angle for why you did it. They may not and don't have to accept it if it's out of the realm of what's normal in their local area. However, what that does is it builds a good rapport with you and your inspector, because he understands that you are following the code book to the best of your ability, and that you respect his authority in the enforcement of these codes, which goes a long way. The HJ, authority having jurisdiction, you'll hear that mentioned all throughout the code book. It might be an organization, could be an office, could be one single individual, could be the same individual for electrical, plumbing, and mechanical. Okay, but they're there for the purpose of interpreting the code, and then also for approving equipment and the materials and the installation procedures that you use while done in accordance with the code. So they are our official, and for the most part, they do a pretty good job. Approval of equipment. Now, who is going to be in charge of approving equipment? Well, of course, it's going to be the AHJ. They're the only ones that have the authority to approve the equipment and materials that are being used. The approval should hopefully, most of the time, be done based on what the product listing is and your installation standard. So when we're talking about what the product listing is, if it's UL listed or listed by an agency that's approved by your jurisdiction, oftentimes, even though we might be mid-code cycle and we got a new product that hasn't made it into the code yet, they may still accept it. 90.4, compliance with the listings. It's the responsible of the AHJ to make sure all appliances and equipment are installed according to the manufacturer's guidelines. This is in addition to following the National Electric Code guidelines. This is not instead of following the guidelines, but in addition to. Now, what are we talking about here? Well, let's give a very straightforward example. What happens if following the code violates the manufacturer's guidelines? Okay, well, that's kind of a loaded question because it just depends on if violating the manufacturer's guidelines, if we're talking about that, is it actually going to change the nature of how the equipment operates in the way that the manufacturer intended it to operate? Because if that's the case, oftentimes the manufacturer's guidelines and the UL listing will win. Because if following the code alters the nature of the way that the equipment was designed to run, then what good is it going to be to follow the code? You actually may be losing some of the safety by altering the way that it's running. You might lose some of the efficiency. So it's kind of a fine line when it comes to manufacturers' guidelines and the code, and when they conflict, it doesn't happen that often. But long story short, the best thing that you can do, check with your code official to see what they're looking for in that instance. It's one of those things where they're going to tell you yes or no, you've got to do it this way or you got to do it that way. They're not going to pick bones with you, and chances are if they're going to tell you no when you ask in advance, they're going to tell you no when you ask afterwards. It's one of those things where it's definitely not easier to ask for forgiveness after you've already done it. Oftentimes, that shows disrespect for your code official, and if they were on the fence, they might not be jumping over to your side of it if you've superseded their boundaries. So keep in mind to always speak with your code official before doing anything questionable. Waiver of requirements. Only the HJ can waive specific requirements of the code or even permit any alternative methods to happen. So there are some people out there that are just really full of ideas, and sometimes they have a little bit better way of doing things. Well, if you're one of those people, just because it's not found in the code or it might be a little bit different than normal doesn't mean that the code official is not going to accept your means of installation or your product that you want to put in. They do want to be included because their job is to provide public safety. They don't want somebody to be unsafe because somebody went off the reservation and did something completely sideways of what's considered normal and it made it unsafe. They need to be included into your decisions there. 90.4 Waiver of New Product Requirements. If the code requires products that aren't available yet, then you're going to be allowed to follow products that are acceptable now or were currently acceptable with the previous code until the new product is out. And then the code official might say, yeah, okay, you're going to go ahead and do it the way you've always done it, but when this new product comes out, you're going to have to start using that. We've seen that several times through the years. Probably the most recent was the advent of GFCIs and arc fault circuit interrupters. The actual arc fault receptacles took for quite a bit longer than the actual breakers to come out. And when the breakers and the receptacles both came out, you could follow several different sections of the code as far as having options on how to install in those areas. But there were some overlap there to where there were requirements that said you could use receptacles here, but they weren't available, so you were able to use the previous requirements until they became available. 90.5 Mandatory Requirements and Explanatory Material. Getting into 90.5, which leads us to clarity on terms. And clarity on terms is quite a big portion to deal with, but we're going to make some fairly short work of it. Shall or shall not is mandatory. Very simple. So it's a very, very important part to remember in the code because it's spoke about throughout the code. But again, like I said, we're making short work of it. Shall be permitted means you can do it, but you don't have to. References to other codes are informational only, but they are not enforceable. 90.5 Approvals and Explanatory Material. Remember, product evaluations are done in a lab. They're not done out on the job site. If the product is listed or labeled or identified in some way that's recognizable and acceptable to the authority having jurisdiction, generally it's going to be accepted in that area. 90.7 Examination of the equipment. Usually an inspector might look at a factory installed or designed panel for its UL listing to make sure that it was actually designed and listed for its purpose, but usually they're not going to get too enthralled in checking all the circuitry unless you've altered it somehow. So if you've actually got into the panel and put holes and other relays or circuitry inside of the panel in addition to what the factory has done, if you didn't do that, they probably are not going to get too whipped up about what you've got installed there. Rule number 6, general requirements. Article 110 deals with the requirements for electrical installations. And more specifically, 110.2 deals with the approval of the equipment. You should only install approved conductors and equipment, and they are supposed to only be installed by approved methods. Okay, with that being said, the HJ has the ability to approve all of them. The conductors, the equipment, and the method by which they're installed by. 110.3b pertains to the installation instructions. Your equipment has to be installed and used as the manufacturer intended. Again, as we spoke about just a short while ago, if the manufacturer's instructions are different than what the code says, and following the code would potentially violate the manufacturer's installation instructions or the UL listing, then chances are you're going to get a pass on that. But it's always important to make sure that you understand where your code official stands on the subject. 110.3b. Make sure that you don't ignore anything, right? It's a violation of the code to ignore listing and labeling instructions found in the code, even, of course, if there's something that you don't agree with. And yes, I have a table here, table 1.1, that deals with torque specs. The torque specs are something that oftentimes get overlooked, and I hear service technicians or installation crews kind of chuckle when we start talking about them, but they are important. They're there for a reason, and even though you might not agree with them, you are supposed to be following even the torque specs. Look at some of the things that are on these labels here. For instance, in the upper left hand corner you see an air conditioner nameplate. Notice where it says maximum fuse or breaker size. Okay, if it says maximum fuse and that's it, with no breaker size or anything like that on there, just maximum fuse size or something like that, that's a command. That's telling you that even though you might have a breaker on the other end, that you have to have a fuse, even though it's going to be redundant, in that circuit. So those things are really key to hone in on and understand what the manufacturers actually wanted. This particular one says fuse or breaker. Notice here on the right hand side we've got a torque screwdriver, which is very popular. Makes short work of having to torque some of the smaller receptacles and things like that, because even the receptacles are going to have torque specs for the screws, usually going to be in the manufacturer's installation guidelines. You can see here on the lower left-hand corner where the receptacles are that you've got all kinds of things indicated on there. You've got your listing mark, the maximum amperage that it's designed to run at. You've got what type of wire is allowed to be hooked up to it. So there's all kinds of things that you'll find imprinted on the device or on the installation instructions or the manufacturer stickers that you're going to have to comply with. Okay, oftentimes you'll see this in residential settings. I would say quite often. Take just a moment and let that sink in. Look both up at the top left and the top right, and you'll see two non-metallic cables or Romex going into these panels, and they're doubled up under the connectors. So why is that frowned on? Well, code says that you're only supposed to have one wiring method per connector type unless it's listed for something different. You know, if you can have multiple wires and it's indicated on a UL listing or something like that, that's fine. Okay, but these aren't. When you go from older residential dwellings to newer residential dwellings, we have so many new circuits that people didn't have decades ago. We have a lot more things that plug in. We have ceiling fans, lighting everywhere, special stuff that they just didn't have room in the old boxes for us to hook up all of this new stuff. And so you'll see guys that'll go in there, do a renovation or something, and they'll have to double lug or change the box. Okay, so let's talk for just a second why they don't want you to double these things up. Why is that? I mean, obviously you can get them tight. If you've ever been back to the shop, you see the lower right or the lower center picture here. You've tightened these things down. You can't move them. I mean, it all but pinches the wire to death. So why isn't that good enough? Well, one primary reason. Remember, all the way back to the first couple of minutes that we spent in the program here, we talked about two things that always go into the code: protect the people, protect the structure. One of the things we're looking at here is structural integrity. Okay, right now, as it sits in that lower middle picture there, that non-metallic cable is taking up the entire fitting. And if you look at it, you would see, if you could move it all around, you'd see there's no light going through there or anything like that. It's very, very tight. However, if you were to take a torch and burn all of that plastic flammable material off of the actual wire, you would notice that there's hardly any area inside of there that's not taken up by that plastic sheathing. So if a fire were to occur and burn all the sheathing away, there's a huge gap in there where the wires run through that. And so if a fire were to break out inside of the panel and burn all the sheathing away, and you had two non-metallic wiring methods doubled up in one connector, there would be a huge gap that fire could spread outside of that panel up in through the joists and to the rest of the house. So that is one, and should be adequate enough, reason as to why they don't want you to do that. Sure, it costs more money to put in a new panel and such, but we're talking about structural integrity. Rule number 7, 110.14. We're talking about electrical connections now. So in dealing with electrical connections, what are we talking about? Well, look at this breaker that we've got right here. This breaker has all kinds of things written on the manufacturer's sticker right on the breaker itself. Okay, one thing that we're looking at is temperature limitations, right? And I've got that highlighted there. But also on there, you've got the manufacturer part number, you've got your UL listing number and everything. You've got all kinds of things on that manufacturer sticker. If you look at if you were to look around on that breaker, you would also see that there are temperature limitations. Right? 6, if we're talking temperature limitations, generally nothing or a 6 will indicate 60 degrees Celsius, and that would help you size off of the table 31015B16 for sizing your conductors based on ampacity. And if it has a 7, it's referring to 75 degrees Celsius column on that chart. And if it's a 9, it would indicate 95 degrees Celsius. So let's look at a couple examples of the different markings that are found on those products. Okay, first of all, we got torque specs. Same breaker, other side. We got torque specs that are stamped right on this device itself. And having those torque specs stamped right on there makes it so there's very little, if any, you'd have to really stretch to have an excuse to not actually torque your lugs. Okay, if you're wondering more about torque specs, okay, 110.14a speaks about them, and then there are other manufacturer specs that you'll find in Annex I. Okay, table 1.1, there's your, I'm sorry, table I.1 is your tightening torque specs. Electrical connections, still we're continuing here. You know, there's all kinds of information. This is off that same breaker. Shows you the kind of wire that you can hook up to it. Notice you see the CU/AL. Okay, there are different ways that the industry indicates whether or not you can use copper or aluminum or either one. Usually Cu or Co will mean that you can use copper. AL or ALR is used for aluminum. So if it says ALCU or COALR, that's going to equal copper or aluminum. That slash in the middle is an either or. Okay, very few devices, fittings, connectors, etc. allow you to intermingle aluminum and copper. There are some out there. This is one set of twisters that is produced by Ideal Products, and this allows you right off the manufacturer's website. It allows you a secure connection for aluminum to copper, and it doesn't lead to any kind of aluminum corrosion, prohibits it. Okay, so this is one indicator that should be pretty widely known for you already, that putting aluminum to copper is not acceptable in all matters, but there are some circumstances and some fittings that you can use. Electrical connections, still in 110.14. Okay, you'll notice that on the back of this receptacle, you'll see the 10 to 14 gauge wiring indicator on there, which is telling you the size of wire that you can have hooked up to it. The type of wire is telling you copper only, and it also says AL with a slash through it, indicating that no aluminum is allowable. Okay, looking at the temperature rating on this, okay, typically the temp rating and type of the metal wire that's accepted will have to be visible and undamaged for the AHJ to accept it. If it's been all scraped up and it can't be read, then it's going to most likely be assumed to be copper only at 60 degrees Celsius terminals, which is the safest rating that an AHJ would be able to give you. Okay, 110.14a, terminals with more than one connector have to be identified. Okay, what do they got to be identified for? Well, they got to be identified to be acceptable to have more than one connector on there. So double lugging is not acceptable either. A lot of people don't consider grounds and neutrals to be included in this ruling, but that's absolutely a false statement. Neutrals and grounds are still considered to be conductors. Here's another example. Most people don't have a problem including the hot wiring or the hot wires in this rule either. Okay, so if you look, terminals for more than one conductor and terminals for aluminum shall be so identified is actually pointed out in this section of code, 110.14a. Okay, and you'll notice center stage right there in the middle of the screen, our mains coming in are double lugged. In reality, if you got a conductor, regardless of the color, okay, whether it's hot, neutral, or ground, they're all included in 110.14a. So make sure that you're taking care of the situation and not double lugging these up. There are some acceptable measures for putting more than one conductor onto a terminal. So it could be that the manufacturer of the terminal just has simply okayed it. So you can have more than one conductor on there. Okay, it could be that you've got one connector that's split into two actual connection points like these all have in the ones marked yes with the arrows, so that you're not actually double lugging anything, but you are making both connections on those actual connectors. When it comes to splices, 110.14b, conductors are to be spliced or joined, and they're supposed to be joined or spliced by devices that are listed for that purpose. Now, one thing you've got to keep in mind when you're looking at this stuff, okay, when you're splicing, the basic rule to follow is when the product is finished being spliced and then reconnected, it must be mechanically sound, okay, so you're not going to pull it apart, and it also has to be electrically secure as well, and it has to have the same insulation value that it had for the circumstance before the product was actually spliced. As you'll notice here, we got a regular box of wire nuts, and it says right in step 3 here that there's no pre-twisting necessary. Now I run into that all the time, and it's not that it's an unusual argument. Arguing about things such as this when it's fairly clear on the manufacturer guidelines right on the outside of the box is just kind of a little bit silly. Okay, so in looking at this, where did this all come from? Well, if you've got bigger wires, then using something to help you twist the wires before you put the larger wire nut on there, okay, may actually aid in doing the process and making it secure. However, it's not mandatory. I once had a gentleman that was really set on the fact that you had to have a minimum 6 twists with a set of pliers, and then you also had to have several twists with the wire nut before it was considered to be electrically sound. Now, there is no such detail in the code book. It just has to be electrically secure and mechanically sound, and have the same provided insulative value as it did prior to being spliced in the first place. 110.14b, splices still. The insulation provided by the splicing device or connector has to have the equivalent protection provided by the conductor itself. Okay, here's some examples of some things that went sideways. As you will notice, there are both aluminum and copper wires inside of the wire nut and inside of this particular outlet, and it really led to a gigantic amount of heat built up inside of the system. And that amount of heat has melted the wire nut and could potentially have caused a fire. It's awfully difficult to say. From 110.14b, continuing on with conductor splices. Okay, in the code, we're talking about the splicing, same section that we've been talking about for the last few minutes. Multi-conductor type UF or type USC cable can be spliced underground with the listed splice kit that encapsulates the conductors and the cable jacket. There's a common misconception that you can't splice underground conductors, and that's not necessarily true, as long as you keep in mind one of the basic rules, which says you have to have the same insulative value as you had before the splice was ever made. 110.14c talks about temperature limitations. Conductors are to be sized to the lowest temperature rating of any terminal. Notice we've got the 9 on there, pretty much dead center in the screen, and that 9 is indicating 90 degrees Celsius. 110.14c1a equipment provisions. If the equipment is rated 100 amps or less, or marked for 14 gauge or 1 gauge conductors, termination shall only happen if one of the following is true. 1. The conductors are rated for 60 degrees. 2. The conductors that have a higher temperature rating, but the ampacity has been calculated using the 60 degrees Celsius column of 310.15b16. 3 and 4 are not mentioned because, we don't use them that often. It's very obscure. Again, this is 110.14c1a. You're certainly welcome to reference this on your own, but again, they're very obscure. If you wanted to know what they are, 3 says if the equipment is listed and identified for the conductors being used, and 4, if you've got motors with a design rating of B, C, or D, and the temp rating of 75 degrees Celsius is permitted provided the amp rating doesn't exceed the 75 degrees Celsius column rating of 310.15b16. So very obscure rating there. 110.14c1b. We were just talking about A, now we're in B, and we're dealing with equipment provisions. If the equipment is rated 100 amps or more, marked with 1 gauge, conductors or larger, termination shall only happen if one of the following is true. The conductors are rated for 75 degrees Celsius. The conductors that have a high temperature rating, but the ampacity has been calculated using the 75 degrees Celsius column of 310.15b16, or the equipment's listed and identified for the conductors being used. Rule number 8, 110.16 flash protection warning. 110.16 deals with arc flash hazard warnings. More particularly, we're going to get into the labeling here coming up. Arc flash warnings have to be located in a visible location for a QP, which is what? A qualified person. Okay, now that is different for some of you that are used to hearing a competent person on the OSHA or safety side of things. Now, a competent person is somebody that simply is named by a person in a superior role. They may or may not have additional training. They may not initially have elevated understanding of the situation or the hazard. Okay, but that's different than a qualified person. There's actually measures that have to be met before a person can be considered a qualified person. Okay, 110.16 arc flash warnings. And other than dwelling units, electrical equipment that could be tested or worked on, okay, which is a huge indicator as to when it's actually applicable, requires a factory or field marked arc flash hazard warning sign. The sign has to meet the requirements in 110.21. So let's look at 110.21b, which is your reference point. What items are required? Well, you warn of the hazard using effective words, symbols, or colors. It's got to be permanently fixed. It cannot be handwritten. And the exception to the handwritten rule are items that are subject to change. So if you've got items that are subject to change, the handwritten rule or policy can be negated. It's got to be able to hold up in the environment, so the conditions that are in are going to really dictate what type of sticker we're talking about. Informational note, okay, NFPA 70E is an invaluable resource. Okay, 2015 is your most current right now. It comes out staggered in years from the National Electric Code. So the next National Electric Code should be out in 2017. So your next NFPA 70E, which is the electrical safety standard, will come out 1 year later in 2018. It contains the guidelines for the electricians when you're talking about determining exposure potential, safe work practices, arc flash labeling. It also gives great advice on how to select the appropriate personal protective equipment. Here's another example of an arc flash sticker being put on. Here are some personal protective equipment selections that you could make. Notice left to right, they get a little bit more intense. Okay, here are some other options once you really get into the arc flash scenario. And one thing that's very important to remember, and you could spread this on to your mechanical friends. Oftentimes when our mechanical friends are up on a rooftop or on a side of a building working on a commercial structure, or in some instances, depending on the area of the country, maybe even a residential structure, that is an elevated amount of voltage. So you got 480 volts. Oftentimes they're not wearing anything to protect them from an electrical shock. Well, the requirement to wear arc flash protection is not just for the safety of the electricians, it's for everybody that's going to work on or test these high voltage products. So make them aware that this is something in their monthly safety meetings that they could be practicing and researching how to use properly out in the field for their own safety as well as everybody else. Okay, here is a nice, indicative caricature of what it looks like as far as an arc flash, what actually happens. We've all seen some of the photos, and we'll have some coming up, of what happens when an arc flash occurs. But there's a lot more science behind it than just the flash and the molten copper and aluminum that shoot out, and the electrical charge. There's a sonic wave. There is all kinds of things that go into the to the behind the scenes study of this stuff. And trying to decide what kind of personal protective equipment somebody should wear is really difficult if you don't understand these different principles that are at play. Notice on the left here, we've got rainwear that has non-meltable material. On the right, we've got rainwear that has meltable material. Okay, now chances are both individuals are going to endure a high amount of heat. Okay, but the point is, the personal protective equipment that was designed to handle the high amount of heat actually worked. So we may have saved the person on the left over the person on the right. And you got to remember, a lot of these studies that they're doing now is not specifically designed only for electricians. It's also designed for general maintenance men and janitorial men and women, because they're going to be on the job site just as much as electricians, so they need to know, okay, what is our baseline personal protective equipment that these individuals should be wearing. Maybe they're not going to have a 500 cal suit on all the time. Okay, but what could they be wearing that could save their life in the event of something going sideways? Okay, this one here, courtesy of Fluke. Okay, if you look at these two pieces of clothing here, you got two very similar incidents, two very different outcomes. You've got arc rated personal protective equipment or personal protective wear on the left hand side, and you've got regular fabric on the right hand side. Okay, here is a picture. You go top left and then across to the right, and then down to the left, middle, across to the right, down to the bottom left, and across to the right. And you will see that this individual, after following that sequence, which this is a mannequin, this isn't actually a person, but this individual would have probably survived. Okay, this is out of NFPA 70E. And you look at this sequence of events here. It shows an arc flash from the initial fault to after it's been extinguished. The initial fault happens there in picture number 2, upper right hand corner, and it's ugly. It's really a huge amount of heat, molten metal, probably shards of metal and gases, a huge pressure wave, all the way down to the last picture there, which shows that this individual may have made it because of the personal protective equipment that he was wearing. Obviously, this is what we are trying to avoid. And this is the purpose behind the code, is to save the structure and save the people involved, all the people involved. 110.22, identifying the disconnects. This is rule number 9. 110.22a, general overview. Each disconnect has to be identified as to its purpose unless its location makes it clear. 110.24, available fault current, which is rule number 10. 110.24a says in other than dwelling units, the service equipment's got to be marked with the maximum available fault current, and it must initially include the calculation date as well. (110.24b) says when it comes to modifications, if the modifications could affect the electrical installation's maximum available fault current at the service, it has to be recalculated and relabeled. With the exception at 124A, for 124A and B, they aren't required in industrial installations when it's clear that only a qualified person will service that equipment. So it's not in an area where general passersby or the general worker bees will be able to get into it. 110.26, spaces about electrical equipment. Rule number 11. (110.26), spaces about electrical equipment. Sufficient space to work on or maintain electrical equipment is required. It has to be kept clear and safe from obstructions all the time. 110.26a talks about working space. If the equipment is working at less than 600 volts or less to ground and could become energized, so we're talking 600 volts or less to ground and could become energized, doesn't say it is energized, but it could become energized, while being examined, adjusted, serviced, or maintained shall comply with 126A1 and A2 and A3. Okay, 110.26A1 talks about these working spaces. If you look at it, the one that we're going to focus on is your nominal voltage to ground being 0 to 600 volts. And you'll notice that there are two distinct separations here, where you got 0 to 150, and you got conditions 1, 2, and 3, and then 151 volts to 600 volts with conditions 1, 2, and 3. A1, dealing with the depth of working space. We got two basic voltage ranges that we're working with here. We've got the 0 to 150 volts at a 3-foot distance, and 151 to 600 volts working at 3 to 4-foot distance. Now, what I'm talking about here is, if you were to look at that chart again, and we'll explain it with a picture here in a moment, if you were to look at that chart again, it doesn't matter whether it's condition 1, condition 2, or condition 3. 0 to 150 volts is still going to maintain 3-foot distance. However, if it's 151 to 600 volts, those conditions change the distance between the two devices. This is what we're talking about. Condition 1. Condition 1 says we've got live parts on one side and it's insulated on the other side. In that instance, 0 to 600 volts is going to equal 3 feet. So it doesn't matter what the voltage range is, 600 volts and below, it's a 3-foot distance. Condition 2, if you've got live parts on one side and grounded parts on the other side, then if it's 0 to 150 volts, it's going to maintain that 3-foot minimum clearance. And if it's 151 volts to 600 volts, it's going to increase the amount of distance you have to have between those two objects. It'd be 3.5 feet. Condition 3 talks about having live, potentially exposed parts on both sides. This would require still a 3-foot distance if it's less than 150 volts, or if it's 151 to 600 volts, it's going to have to increase the space between those objects to 4 foot because of the increased amount of danger or potential for danger. Notice our spacing here. There's all kinds of stuff going on in this picture, but some of the more questionable areas would be towards the back of this room. Now again, looking at this, I'm sure that most of these things that are in this room were added after any kind of inspection. However, doesn't change the fact that we do have potentially dangerous situations here with those meters in the back. Now, obviously, things have certainly gone sideways here. We've got some service coming in here, and it is all over the place. It looks like potentially there's some mold on the wall, maybe some mildew on the wall, and so we've got some moisture down there. Things are rusted. We're below level, so we've got all kinds of things going on in this picture here that makes the installation probably not comply. Now, what do we got going on here? Hey, notice we have no cover on this box. Everything is exposed inside of there. There's no, because of no cover, and we have the potential, that's a gas pipe there. We have the potential of a leak, possibly followed by an electrical spark or arc, leading to all kinds of not good. Here's a few different things that come up from time to time. Now, I'm not going to tell you the one in the upper left comes into play all the time. Somebody really had to want to play a trick on somebody. That condensing unit for the air conditioning system is upside down. So very unusual that somebody would do that. The one in the upper right, however, comes into play all the time. You can see clearly this is on a rooftop. They have the disconnect hooked right to the condensing unit. It is on a panel that is a removable panel. That panel is able to come off in the event that we have to make a repair on the condenser coils or need to clean the condenser coils. So you could be subject to having to do something a little bit different there. Putting it on some kind of a fixed 4x4 coming up through the ground, or stabilized on the rooftop or something like that. You know, something other than on that condensing unit. I'm not going to say that this wasn't inspected and accepted, because some inspectors are fine with that, but other ones are not, and that's why you have to ask your inspector what they would accept and what they wouldn't. The one in the lower left is just silly. Mechanical code and most codes actually indicate that you have to have 30 inches wide, 30 inches deep of a working space in front of the serviceable panels. This guy clearly does not have that in that lower left-hand picture. If you notice really clearly, there's somebody holding that guy. You can see his arms wrapped around his waist from inside of that building. And then the lower right one has been around for a little while, but always interesting. caption on that really should read, who should you call? Plumber or an electrician? 110.26A1A, dead front assemblies. You don't have to leave the room or leave any room for working space in the back or the sides of the equipment if all the connections and the work and testing can be done from the front of the equipment. 110.26A1B, low voltage. If the AHJ gives you some permission, the working space can be diminished if the equipment's not operating at more than 30 volts AC or 60 volts DC. 110.26A1C deals with existing buildings. Now remember, existing buildings fall into a gray area that basically, under normal situations, you would be exempt from following a lot of the new code standards if your building was up to code when it was built or at last update. So just because your code changes doesn't mean you have to bring all the building and structure up to current code. That would be very expensive for building owners, and I would have a feeling that we would see a lot less small business folks that would work outside of the house than we do right now. But when it comes to existing buildings, if written policies are in place to prohibit both sides of a walkway that contain energized parts on both sides from being opened at the same time, the AHJ can grant less clearance in existing buildings. So you've got a walkway, exposed parts that are on both sides, or energized parts on both sides, and there has to be some kind of a policy in place that makes it so that they both can't be exposed while energized at the same time. 110.26A2, the width of the working space. For equipment 30 inches wide or less, the working space has to be at least 30 inches wide, even if the equipment is less than 30 inches. 110.26A2, the doors have to be able to be opened to at least a 90-degree angle. And if equipment is over 30 inches wide, then the new working space, instead of being 30 inches, will then be the width of the equipment. So it's going to be at least a minimum of 30 inches. Even if the equipment's only 15 inches wide, you've got to have 30 inches there. However, if the equipment is 6 feet wide, the new working space is now 6 feet. 110.26A3, the height of the working space. For equipment 6.5 feet tall or less, the height has to be 6.5 feet from the floor, grade, or the platform, minimum. There is an exception. If you have an existing dwelling unit with a service that has less than 200 amps, which could be fairly common in mobile homes and manufactured housing, the HJ could permit the height requirement be less than 6.5 feet. Again, this all goes back to being in contact with your authority, having jurisdiction, your inspector, and understanding what he's okay with and what he's not. If the equipment is taller than 6.5 feet, if the equipment's taller than 6.5 feet, then the new height of the working space is going to be the height of the equipment. So you got to have a minimum 6.5 feet without the authority having jurisdiction, giving you any clearance for less than that. So minimum 6.5 feet, even if it's 3 feet off the ground, you got to have the minimum 6.5. However, if your equipment is 10 feet tall, the new height of the working space is 10 feet from the floor grade. What about having stuff mounted above or below? We see this a lot. It's okay to have other electrical equipment above or below, but in the same working space, height-wise, of course, as long as it doesn't infringe more than 6 inches beyond the front of the electrical equipment. This is probably one of the least favorite portions of Article 110 for most electricians. It allows people to store stuff in the area that has electrical equipment. 110.26b says nothing is allowed to be stored in the areas designated as the working space. However, it can be in the same room as the electrical equipment as long as it's not in the qualified working area, working space, and if parts that are normally enclosed and are exposed only in the event of needing repair or checking, and they're guarded. So if you've got parts that are normally going to be guarded and are only exposed for inspection and repair, you're good to go. 110.26c talks about entrance and egress from the working space. 110.26c1 talks about minimum requirements. At least one entrance is required to achieve 110.26c1. Most people don't realize that the requirement's only one entrance and egress unless you're over 1200 amps and over 6 feet wide, and it contains switching, overcurrent, or control devices. And unless 110.23c2a or b are met. So your minimum requirement is one entrance. 110.26c2 deals with large equipment. If it's over 151 volts with live parts on one side and grounded parts on the other, you got to have at least 3.5 feet of workspace on the front side of the equipment. We talked about that already. Okay, and we're talking about equipment that is big. Look at the parameters, 6 feet and 1200 amps. If the location allows an unobstructed entrance and exit, only one method of entrance and egress is required. That's C2A. 110.26c2b talks about extra working space. If the workspace required in Table 110.26a1 is doubled, and the distance from the equipment to the nearest edge of the entrance or egress complies with that same table, you only have to have one entrance. (110.26c3) deals again with large equipment. The equipment that are 800 amps or more and less than 25 feet from the closest edge of the working space, those entrances and exits have to have panic hardware. Now, we've seen panic hardware forever, but remember, it doesn't always have to be the big old bars like you see in the left-hand side here. Okay, those are usually preferable because it covers the whole side of the door. You could literally fall into it without the use of hands or sight and fall out of the structure. But the requirements have been loosened up in quite a few areas to where now paddle handles, like you see on a common household, however, that can't be locked, are also acceptable. 110.26d, illumination. Indoor electrical service equipment has to be illuminated. It just has to. If you're going to work on it, you're not going to use a miner's light or something like that unless there's no power to the room, or you're in an outage or something like that. But any automatic illumination, which is so popular nowadays, having the occupancy sensors and whatnot, they have to be able to be overridden. Okay, what would be worse than having your hand inside of a panel and concentrating on moving, but not, or on the checking of the equipment, but not moving enough to maintain the occupancy sensor, and it shuts off. And you've got to take your hand out of a live piece of equipment and wave it so you get light again. And that would be absolutely a horrible feeling. So the 110.26d illumination area that we're talking about here is talking about these occupancy type sensors, and it says that you can have them in those areas, but they have to be able to be overridden in the on position. 110.26e talks about dedicated equipment space. All switchgear, panel boards, motor control centers have to be in a dedicated space and protected from damage or comply with E1 through E2. Well, indoor installations also must comply with 110.26 E1a through D. So what is 110.26 E1a? Dealing with dedicated electrical space. It says dedicated space is different than working space, okay, because it refers to the actual width and depth of the equipment, and a space equal to that's got to extend from the floor to 6 feet above the equipment or the structural ceiling, whichever's lower. And when it comes to structural ceiling, we're not counting ceilings with removable panels, such as drop ceilings. So you have to keep that in mind. So 110.26 E1a, dealing with dedicated electrical space, it extends beyond the top of the equipment, 6 feet, or to the top of the ceiling, whichever comes first. The exception, suspended ceilings can be in the 6-foot zone. Remember that. Remember that this is indoor, not outdoor, and no piping, ducts, leak protection, or any other equipment can occupy this area. 110.26 E1b talks about foreign systems. Okay, and here an example would be a condensate pipe. You can have materials and foreign equipment above the dedicated equipment space as long as you take measures to make sure that if something goes wrong, like a leak in a condensate pipe, you have protected the electrical equipment below, either with a shield or some kind of barrier or something like that. But keep in mind, you have to ask the AHJ. It has to be approved by the AHJ in order to make this okay. 110.26 E1c deals with sprinkler protection. Sprinkler protection is allowed for the dedicated space as long as it complies with section A and B. 110.26 E1d Suspended ceilings. If the ceiling, like a drop or suspended ceiling, doesn't add structural integrity to the building, it isn't considered to be a structural ceiling. That's why we were talking about earlier, just a few minutes ago, about your dedicated working space above the actual equipment. It extends 6 feet above the equipment to the ceiling, or 6 feet, whichever comes first. So if the ceiling is at 10 feet above the equipment, you only have to go up 6 feet. But if the ceiling comes first, that's fine. But you can't consider the suspended or drop ceiling to be your structural ceiling to end that dedicated space. They can be in the 6-foot zone, but they can't be considered the top of the 6-foot zone. 110.26F, locked equipment rooms or enclosures. Okay, this is always a big area of contention. Should we or should we not be allowed to lock the equipment rooms. Well, there's some people you just don't want in there. You don't want to leave it open for anybody to get in there. You only want qualified people in there, or you have to have access to it. Okay, so the code has incorporated for quite a while now 110.26F, which deals with that. If you have a locked or secured electrical enclosure, it shall be considered accessible to a qualified person. Okay, because that qualified person will probably have access to it. Key, thumbprint, eye scan, whatever the case may be, a qualified person is going to have access to that. Okay, obviously, when it comes to access, different people take different measures. At this point, you've reached the end of the actual online training, so do not forget, if it applies, you will see questions pop up. Different states require different amounts of questions for you to answer in order for you to get credit for this course towards your license. After you answer said questions, if they apply, the certificate will pop up and you will be able to print out your certificate and or save your certificate, and I encourage you to do both so that you have it in your possession. That is a requirement for every state that requires electrical CEU based training. Thank you and have a wonderful, wonderful day.